You know, millions of us start our day with a cup of tea, but have you ever stopped to think about what's actually happening inside that simple cup? There's this incredible chemical drama unfolding. So in this explainer, we're going to unravel that mystery and get to the bottom of a really powerful concept, chemical balance. So let's kick things off with a question you've probably wondered about. You pour a cup of black tea, squeeze in some lemon, and boom, it gets lighter. Why? It's not just that you're watering it down. No, something way more fundamental is going on at the molecular level. The short answer? You are literally watching a chemical balancing act happen in real time. That color change is a huge clue that you've just nudged a chemical reaction in one direction, and, as we're about to see, you can just as easily nudge it right back. To really get what's going on in our tea, we need to dig into this massive idea in chemistry. It's constant balancing act. Scientists have a name for it. They call it dynamic equilibrium. So, what in the world is chemical equilibrium? It's easy to think a reaction just kind of stops when it's finished, but that's not really what happens. Instead, it hits this state of perfect dynamic balance. The forward reaction, stuff turning into other stuff, is happening at the exact same speed as the reverse reaction, where the new stuff turns back into the original stuff. Okay, let's break this down. Think about static versus dynamic. Static is, it's static, like a ruler balanced perfectly on your finger. Nothing's moving, right? But dynamic equilibrium? That's way cooler. It's like you're running on a treadmill. You are absolutely in motion. You're running forward, but the belt is pulling you back at the exact same speed. The result? You don't actually go anywhere. You're in a state of perfect active balance. And that is exactly what's happening with the molecules in our tea. Okay, so if these reactions are all perfectly balanced, how do we get them to do anything? Like, say, change the color of our tea? Well, this brings us to the key that unlocks the entire mystery. We have to stress this system. And for that, we need to talk about 6.Chateliers' principle. The principle itself is actually beautiful in its simplicity. It just says when a system at equilibrium is stressed, it will shift to relieve that stress. You can think of it like a seesaw. If you add some weight to one side, what happens? The whole thing tilts to try and find its balance again. Well, chemical systems do the exact same thing. 6.Chateliers' principle is basically a chemist's crystal ball. It lets us predict exactly how a balanced system is going to react when we stress it out by changing things like how much stuff is in there, or the temperature, or even the pressure. If you understand this principle, you can basically control the reaction to get what you want. All right, enough theory. Let's get this out of the textbook and into the lab by putting the principle into practice. It's finally time to solve our tea mystery. First up, that cup of tea. We're going to see that lemon effect in action. The stress we're going to apply here is changing the concentration of acid, and we'll just use some regular household vinegar. Then we'll see if we can reverse it with a base, good old baking soda. The setup couldn't be simpler. We've got 3 test tubes of tea. One is our control, so we're not going to touch it. We'll add a splash of vinegar to the second and a pinch of baking soda to the third. And then we just watch the magic happen and check out the results. Just like we thought, the control sample stays that dark brown color. But look, adding the vinegar stressed the system and the tea turned light brown. Then, adding the baking soda, a base, did the total opposite. It made it even darker. You can literally see the equilibrium shifting back and forth. So what is going on here? Well, the dark-colored molecules in tea can react with acid. When we dump in the vinegar, we're adding a ton of acid, right? That's our stress. To get rid of it, the system shifts, and the tea molecules hook up with the acid to form a new, lighter-colored thing. Then, when we add the baking soda, it mops up all the acid. So now the stress is a lack of acid, and the system shifts back the other way to rebalance, bringing the dark color back. It's 6.Chateliers' principle, plain and simple. Okay, so that's what happens when you stress a system by changing the concentration. But that is not the only trick up our sleeve. Let's see what happens when we use a totally different kind of stress, temperature, on a completely different reaction. For this one, we're going to use a classic chemistry demonstration, the iodine-starch complex. When you mix iodine and starch, you get this really deep blue-black color. We'll take one test tube of this stuff and stick it in a hot water bath, and another one into an ice bath, just to see how heat and cold mess with the balance. And wow, once again, the results are pretty dramatic. Our control sample at room temperature is that deep blue-black color. But when we add heat as a stress, poof, the color completely disappears. Then, when we chill it down in the ice, the color comes roaring back even deeper and more intense than it was before. The equilibrium is shifting all over the place. So, why does that happen? It turns out that the reaction that makes the pretty blue-black color also gives off heat. It's exothermic. So, we can actually think of heat as a product of the reaction. Now, follow Le Chatelier's principle. If we add more of a product, in this case heat, the system says, whoa, too much, and tries to get rid of it by shifting backward. And when it goes backward, the color disappears. Then, when we cool it down, we're removing heat, so the system shifts forward to make more, and the color gets even deeper. Now, there's a really important reason we chose to use tea and starch for these demos. It's not just because they're cool to watch. It gets right to the heart of a huge movement in science called green chemistry, and why it's so important for a safer, more sustainable future.
So, yeah, why did we use tea and starch? I mean, traditionally, to show these same principles in a chemistry class, you'd be using some pretty gnarly chemicals.
The old school way of teaching this often involves toxic heavy metals like cobalt and chromium. And yeah, they work, but they are so hazardous for people and for the environment. The green way, what we just did, we just used simple things from your kitchen. And the best part? The leftovers are safe enough to just pour right down the drain after you neutralize them. I mean, that is a huge difference. This whole approach is the very core of green chemistry. It's a philosophy, really, guided by a set of principles all aimed at making chemistry less hazardous from the ground up. Reducing waste, preventing pollution, and just designing safer processes and chemicals to begin with. And this simple lab we just walked through, it hits on several of the key principles of green chemistry. By using tea and starch, we're using renewable resources. By avoiding those nasty heavy metals, we designed a way safer experiment. It's all about being smarter and way more responsible with our science. So here's the big takeaway. Powerful, fundamental chemistry isn't something that's just locked away in a high-tech lab full of hazardous materials. Nope. It's happening all around us, every day, in our kitchens and out in nature. And even better, we can explore and understand these incredible principles in a way that is profoundly safe for us and for the planet. And that brings us to a final thought for you to chew on. Now that you know about dynamic equilibrium and this constant balancing act, what other little bits of magic in your daily life do you think are really just chemistry finding its perfect balance? Thanks so much for joining this explainer.